What's up, everyone? I'm getting a series kicked off here just for the college students for a while. I'm going to be focusing on content for your exams, your homework, trying to get you ready for those with the end of the semester coming up. We're going to get kicked off with rotational motion, and we're going to do some multiple choice, some free response questions to help you guys get ready. And we're going to try to keep it simple. We're going to try to keep it easy and understandable for you guys. Keep it practical. All right, see you soon. All right, so we're going to start out our series on angular motion with a situation that involves balanced torques. So I'll let you read the problem on your own if you'd like to, but basically the situation is that we've got a mass of m balanced with on a rigid bar that's horizontal with another mass m1. And we have another situation where it's balanced with another mass of m2, and they're at different lengths in both cases. We have L1, L2. We want to make sure that the torques are the same. So we'll remember here that our torque is equal to force times the distance from the rotation. So in this case, we have one force here that's equal to force of weight, and we've got another force over here, likewise force. So we're going to call, in our case here, we're going to say that positive is clockwise. So if we're going to balance our torques in the first case, and I'm going to call this case 1 over here, and this will be case 2. So if we're going to balance our torques in the first case, we would have a torque due to the to M1, which would be M1 times gravity, and its distance would be L2, distance from the point of pivot. And so this would cause a clockwise rotation, so that'll stay positive. And the other mass, just m, the force would be mg, and the distance from rotation is L1. And we know that this is negative because it's a counterclockwise rotation. And usually we would set this equal to I omega, or the moment of inertia times the angular acceleration, but we know that this is remaining constantly horizontal, so we know that the angular acceleration is just 0, and so we're going to leave that there at 0. All right, so we'll set these equal to each other, and we will say m1, and we will say m1 GL2 equals mgl1. Our g's cancel, and we get m1 L2 equals ml1. All right. So now let's go over to our second case. The diagram on the right-hand side, we'll do the exact same thing. We'll balance our torques, and we'll get m2 times g, the force of weight, times the distance from its pivot, which is L1. And we know that this is a counterclockwise rotation, so that will be negative. And the other torque would be mg times L2. And that's clockwise, so it's positive. So we set that equal to 0, it stays horizontal. So we have m2 times g L1 equals mg L2. All right. Again, our g's cancel, and we get m2 L1 equals m L2. And so they were asking us about we need to find the value of the mass, the little mass m, in terms of the known masses. So we need the mass as a function of m1 and m2. So if we look at these, we have two equations here as of right now. So we have equation 1 from the left-hand side case, and we have equation 2 right here. So I'm just going to label this EQ1, and this is EQ2. So as of right now, we need the mass in terms of M1 and M2, and we have lengths in our equation, but if we look at our options A, B, C, D, none of these options have length in the equation at all. So we're going to need to solve for M, but get rid of these lengths. So I'm just going to start by solving equation 1, solve EQ1 for L2. So let's just start out by doing that. So we'll solve for L2 and we'll get L2 equals M L1 divided by M1. Now we will sub L2 into equation 2. And that will help us to get rid of our lengths and just have an answer of mass in terms of the other masses. So we will have M2 L1 equals M times M L1 over M1. So our L1s cancel, and we get M2 equals M squared over M1. So then M squared equals M1 M2, and M equals square root of M1 times M2. So this is our answer right here, and let's go up and see if that is a possibility. And we see that option D has exactly that answer, and so there we go, we got it.